Imagine one electric motor so powerful that it made the entire car industry rethink what an electric vehicle can actually do. It's not a bigger battery or a new screen, it's a piece of engineering hidden inside, spinning thousands of times per minute. For years, people said Tesla's advantage would disappear once traditional automakers like Ford, Toyota, and BYD got serious. But then Tesla showed something that reminded the world why this company is different. The Model S Plaid became a warning sign, a quiet four-door sedan that could embarrass million-dollar supercars at a traffic light. The secret: the carbon-sleeved rotor. This technology allows the motor to spin at extremely high speeds while staying stable under the most brutal centrifugal forces. Standard metal rotors expand and fly apart at high speeds. Tesla's carbon wrap holds everything together with incredible precision. If it's so impressive, why can't rivals simply copy it? Why do they fail to reproduce this at scale? This is a story about manufacturing, precision, and the hidden battle that could decide the future of the entire EV industry. To understand this, we need to go back. In the early 2000s, electric cars were seen as slow, strange experiments. Then Tesla entered the market with a mission. Electric cars shouldn't be a compromise. They should be the most desirable cars on Earth. From the Roadster to the Model 3, each step pushed the boundaries. But the Plaid motor is the ultimate engineering flex. It delivers performance that once belonged only to the most extreme supercars. The question is, who can keep up? As we look toward the next generation of EVs, the winners won't just have better software, they'll have better physics. Will the traditional giants survive this revolution, or is the gap now too wide to close? Let's break it down. The numbers alone are shocking, but the deeper story is the engineering behind them. A gasoline engine has thousands of moving parts. It needs fuel injection, pistons, valves, exhaust systems, cooling systems, transmissions, and constant mechanical coordination. An electric motor is different. It can deliver torque instantly. It can respond with incredible speed. It can be smaller, simpler, and more efficient. But that does not mean electric motors are easy to perfect. In fact, when you push an electric motor to extreme performance, the challenges become brutal. The motor spins at incredibly high speed. The rotor inside the motor is exposed to enormous centrifugal forces. Heat builds up, materials expand, magnetic forces become harder to control. Tiny imperfections can become major problems. At normal speeds, a rotor can behave predictably. But when you push it toward extreme RPM, every weakness becomes dangerous. The faster a rotor spins, the harder it tries to pull itself apart. This is where Tesla's carbon-sleeved rotor becomes so important. In a simplified way, Tesla uses a carbon fiber sleeve around the rotor to help hold it together under extreme rotational forces. Carbon fiber is light, strong, and excellent at handling tension. By applying it around the rotor, Tesla can help the motor stay stable. That stability allows the motor to produce huge power without losing control. This is not just about making the car faster for a headline. It affects the entire driving experience. A lighter and more stable motor can help with efficiency. Better thermal behavior helps with consistent performance. A stronger rotor design can help the car deliver repeated acceleration without falling apart under stress. And when all of this works together, you get a vehicle that feels almost unreal. That is why the Model S Plaid became such a symbol. It was not only fast, it was fast in a way that changed expectations. Before Tesla, people expected a supercar to be loud, low, and uncomfortable. Tesla put terrifying acceleration into a sedan with seats, storage, software, and daily usability. That is the psychological shock. Tesla did not just build a fast electric car. It made extreme performance feel normal. And once customers experience that, it becomes very hard for traditional automakers to make excuses. But here is where the story becomes more interesting. The idea of wrapping a rotor with carbon fiber may sound simple, but manufacturing it is incredibly difficult. This is where many people misunderstand Tesla. They look at the concept and think competitors can just copy it. But in advanced manufacturing, knowing the idea is not the same as being able to execute it. You can know the recipe and still fail to cook the dish. You can understand the design and still fail to build it at scale. Why? Because carbon fiber and metal do not behave the same way. They expand differently when temperature changes. They react differently under stress. If the carbon sleeve is applied with the wrong tension, the rotor may not perform correctly. If the material is not positioned precisely, balance can suffer. If the manufacturing process is inconsistent, one motor may work beautifully while another fails under pressure. In a performance electric motor, tiny mistakes can become massive problems. This is why Tesla's advantage is not only the motor design, it is the ability to manufacture that design repeatedly. The true challenge is not making one impressive prototype. The true challenge is producing thousands and thousands of motors with consistent quality, at automotive scale, with cost control and reliability. That is the difference between a technology demonstration and an industry advantage. And this is where Tesla's manufacturing culture matters. Tesla has always focused heavily on building not just the product, but the system that builds the product. The factory is part of the technology. The production line is part of the advantage. The software, sensors, quality checks, robotics, materials, and engineering feedback loops all become part of the final result. This is why opening patents does not automatically destroy Tesla's advantage. Tesla's patent pledge means that, under certain conditions, the company says it will not initiate patent lawsuits against parties using its technology in good faith. But a patent document is not a factory. It is not a trained engineering team. It is not a supply chain. It is not a quality control system. It is not years of manufacturing experience. Rivals can study the idea, but they still need to build the machine that builds the motor. And that is the part that cannot be copied overnight. This is the hidden lesson of Tesla's motor technology. The secret is not only in the design, it is in the execution. That is why rivals are under pressure. Rivian is also impressive, but it is playing a different game. Rivian focuses on electric trucks, SUVs, adventure vehicles, and fleet opportunities. It has a loyal audience and strong design identity, but in terms of extreme performance motor technology, Tesla still commands a very different type of attention. Ford and GM have another challenge. They have history, dealerships, manufacturing experience, and brand recognition, but they are carrying the weight of the old industry. They must protect gasoline vehicle profits while investing billions into electric platforms. They cannot move as cleanly as a pure EV company. Their business models are split. Their organizations are complex. Their supply chains are old and new at the same time. That makes radical technology shifts harder. And then there is BYD. BYD may be the most serious threat to Tesla globally because it attacks the market from a different angle. BYD has battery control, production scale, cost advantages, and a wide range of affordable vehicles. In many parts of the world, BYD is becoming the EV company normal buyers can actually afford. That is dangerous. Tesla can dominate headlines with performance, but BYD can dominate streets with pricing. And in the real world, cost often wins. This is why Tesla's motor technology matters, but it does not guarantee total victory. Better engineering does not always beat lower cost. A faster car does not always beat a cheaper car. A more advanced motor does not automatically win every market. But Tesla's advantage is that it does not compete on only one layer. It combines software, battery systems, charging infrastructure, and performance. BYD's strength is cost and scale. Tesla's strength is integration. And the race between those two approaches may define the future of electric vehicles. But we also need to be honest about Tesla's challenges. The carbon-sleeved motor is impressive, but it is not cheap or simple. This type of precision manufacturing requires advanced machinery, expensive materials, and strict quality control. Can Tesla bring this kind of motor technology into lower-cost models, or will it remain mostly a premium performance feature? If the technology stays limited to expensive cars, it strengthens Tesla's image but may not transform the mass market. That is why Tesla's motor breakthrough should not be seen as the end of the EV race. It should be seen as a warning shot. Tesla is telling the industry that it is not done innovating. While competitors try to catch up to Tesla's past, Tesla is still pushing into new layers of performance and manufacturing. And that creates pressure. It forces rivals to move faster. It forces legacy automakers to rethink electric powertrains. It forces BYD to keep improving beyond cost advantage. It forces Lucid to prove it can scale. It forces Ford and GM to decide whether they are truly committed to electric vehicles or still protecting the old world. But the most fascinating part is that Tesla's motor technology may matter beyond cars. High-performance electric motors are not only useful for sedans, they are important for trucks, industrial systems, robotics, energy infrastructure, and possibly even future electric aviation. Electric aircraft face enormous challenges because propulsion systems must be light, powerful, efficient, and reliable. Any technology that improves power-to-weight ratio and thermal stability becomes interesting. That does not mean Tesla is about to dominate aviation tomorrow. That would be an exaggeration. But it does mean the lessons from Tesla's motor engineering could influence industries beyond passenger cars. The same is true for robotics and energy systems. As the world electrifies, efficient motors become more important everywhere. Factories need them. Pumps need them. Transportation systems need them. Automation needs them. If Tesla continues developing advanced electric drive systems, the company's knowledge could become valuable across a much larger clean energy economy. That is why Tesla should not be viewed only as a car company. It is increasingly a company built around energy, mobility, software, batteries, motors, manufacturing, and artificial intelligence. The car is the most visible product, but the deeper strategy is much bigger. Tesla wants to build the hardware and software platform for a world that runs on electricity instead of fossil fuels. That is a much larger ambition than simply selling fast sedans. But ambition alone is not enough. Tesla must execute. It must scale technology. It must reduce costs. It must maintain quality. It must keep customers loyal. It must compete with China. It must handle regulation. It must prove that future products are not only exciting, but also profitable. And that is why the next few years will be critical.